everyone, welcome back to my channel. Today we are doing the questions on proving similarity. Well, we have already done the theory, and if you haven't watched it, I have attached the link in description box. You just go through it and it will help you. And also I'm running GCSE batch classes for all subjects at just £6 per hour. And if you need any class, and these are just micro batches, very small number of students, like 3 or 4, not more than that. That's it, very small batch classes. And if you need classes one-on-one or group classes, any from year 1 to year 13, that is still A levels, you just have to drop us an email at exacademy@gmail.com, and we'll coordinate from there. If you need the like mock papers, if you want to sit for like the test series, or if you need the complete material, you can purchase and email us at exacademy@gmail.com. And if you're looking for free worksheets and the free notes, that are also available in our website, which is exacademy.com. So like all these things that we do here on YouTube, like the questions and the like the theory part, they all are available on our website. So let me start with the question number 1. In the figure given above, prove two triangles are similar. Whenever we prove the similarity of the triangles, it's by AA, AAA, SAS, or SSS similarity. So in the figure given above, prove two triangles are similar. So first thing is we have to see what all values are given. Angle A is given as 30 degrees. This is 30. Angle B is given as 100 degrees. And angle F is equals to 50. So this is 50. Angle E is equals to 100. This is 100 also, and this is 30. If I apply an angle sum property, 100 plus 50, so third is definitely going to be 180 minus 150, because all the angles, sum of all the angles of a triangle is always 180 degrees. So this will give you 30 degrees. And you can clearly see that 100 and 100, 30 and 30, these two corresponding angles are equal. So angle B is equals to angle E is equals to 100 degrees. Angle A is equals to angle D is equals to 30 degrees. So by AA, that is angle, these two figures or these two triangles are similar. So we have proved the similarity. So this is one of the kind by which we can prove similarity. Moving on to the next question. In the figure given above, two regular hexagons are given. Prove that these hexagons are similar. First thing is, for triangles we have the specific SAS, AA and SSS kind of similarities, but for other figures only two things that you have to keep in mind. You have to prove that the corresponding angles are equal, or if you can prove that the corresponding sides are in ratio, they are bearing a constant ratio. Here we can clearly see, I can prove their sides are not given obviously in this case, but we can prove that the corresponding angles are equal because it's mentioned that two hexagons are regular hexagons. And if two hexagons are the regular hexagons, so we know doesn't matter what side is given, the angles, each angle of a regular hexagon or any regular figure is always same. So by applying the formula, which is n minus 2 times 180, this will give you sum of all the angles of a given figure, of a given polygon. So how many sides are there in this polygon? Obviously 6 sides. So n represents 6. So 6 minus 2 times 180. So that will give you 720. This will give me 720. That means sum of all the angles of a hexagon, not necessarily regular, for any hexagon is 720. Since these two are regular hexagon, so I need to divide. We know that all the angles are same whether for this hexagon or for this hexagon, and sum of all the angles of a hexagon is 720 for this and for this as well. And there are 6 sides, that means 6 angles. So all angles are equal. So which means each angle is equals to 120 degrees. So 720 over 6 will give you 120 degrees. That means each angle of both hexagons are 120 degrees. That means this is 120, this is 120, this is 120, similarly this is 120, and we have proved that all corresponding angles are equal. And if all corresponding angles are equal, that means clearly this is a similar figure. So these both hexagons are similar. Moving on to the question number 3. In the figure given above, AB is 2 centimeters, ED is 10, AC is 5, DF is 25, angle BAC is 30, angle EDF is 30. Prove that above two triangles are similar. Angle EDF, that means this angle is given as 30 degrees, and BAC, that means this angle is 30 degrees. And if I see AB over ED, because I told you that corresponding angles are equal, but the corresponding side should bear a constant ratio. AB over ED will give you 2 over 10, which is 1 over 5. Now I need to divide another corresponding sides, which is CA over DF, which is 5 over 25, which will give you 1 over 5, which is again the same constant ratio. And angle A is equals to angle D is equals to 30 degrees. So by SAS similarity, both triangles are similar. What's SAS? That means side, angle, side. They have to be in particular order. Side, then angle, then side. But the sides shouldn't be equal. Sides should be in ratio. Moving on to the question number 4. In the given figure above, BD is 4 centimeters. That means this BD, this part is 4 centimeters. DA is 8 centimeters. This part is 8 centimeters. BC is 18 centimeters and this EC is 12. So if this whole is 18, this part is 12. So obviously this is going to be 6. And we have to prove triangle ABC and BD are similar. So I can just write BD, because which is one side of this smaller triangle BDE, and BA is the side of another bigger triangle, because we are trying to prove triangle ABC and BDE. So we just have to write ABC and BDE. So in ABC whole AB and BD is that BD. So their ratio AB over BD, which is 12 over 4, that is 3. Similarly, the another corresponding side, the other side, another two corresponding sides are BE, and here under ABC I'll write BC, and BE, which is BC over BE, will give you 6, and over 18, which is 18 over 6, will give you 3. And we know angle B is equals to angle B, which is common in this both case. So by side, angle, side, we can prove that these two triangles are similar. So by SAS, we have proved these two triangles are similar. Now, in the given figure above, triangle ABC is an equilateral triangle. AD is 2 centimeters, AC it's 15 centimeters, EC is 10 centimeters, AF is 7 centimeters. So let me just label each one of them. So AD is 2 centimeters, this is 2 centimeters given. AC is 15 centimeters, which is this whole AC is 15 centimeters. The good part is it's given it's an equilateral triangle, so all the sides are 15 and 15. Now EC is 10 centimeters, so this part is 10 centimeters. So if this is 10, that means clearly BE is going to be 5 centimeters because this whole is 15. EC is 10 centimeters. Okay, now AF is 7 centimeters. So AF, sorry, this is actually 6. This is 6 centimeters. This part is 6. So AF is 6 centimeters. And what else is given? Okay, it's fine. So now we have to compare BAE and DAF. What all sides of BAE are given? Let me see. BAE is this. Two sides are known for BAE, which is BE, that is 5, and this one BA, which is 15 centimeters. So BA being 15 centimeters. Now DAF is this smaller triangle. AD is given as 2 centimeters and this AF is given as 6 centimeters. Let me divide them. 5 by 2 will give you 2.5 and 15 by 6 will also give you 2.5. That means, yeah, they are bearing a common ratio. Also, this angle A and this angle B, they both are equal and they are equals to 60 degrees because in an equilateral triangle, all the angles are 60 degrees. So, by SAS, we have proved its similarity. Moving on to the next question. Question number 6. If AB is parallel to DE, then prove the triangle ABC and DEC are similar. So ABC, that means this smaller one, and DEC, that means this one. If these two are parallel, then angle A is equals to angle E, clearly. So let me compare ABC and DEC, and angle A is equals to angle E. Why? Because these two lines are parallel and this one is a transversal, clearly. This one, let me draw it properly. This one is a transversal, so this angle and this angle are forming alternate interior angles. So which means they are equal by alternate interior angles. Similarly, angle B is equals to angle D, which is again because of alternate interior angles. Also, angle C is equals to angle C, which is angle ACB is equals to angle DCE because of vertically opposite angles. So by AAA, we can prove these two triangles are similar. In question number 7, it says in the figure FDGH is a trapezium. That means this is a trapezium. And they have given that EFD, that means this triangle and this bigger triangle, this one, they both are similar. Then we have to prove this angle X is equals to angle Y. So first thing is we have to take the use of the trapezium. So FDGH is a trapezium. So we'll be using this one. So this and this, these two are parallel lines because it's a trapezium and it's a transversal. And if it's so, then one thing for sure I can do is this angle is equals to this one. Okay. Similarly, there is one more thing that we can use because these two are parallel lines. So this is also a trapezium. This is also a transversal, which means this angle Y is equals to this one. This is also angle Y. Similarly, if this is angle Z, say for example, then this angle will also be Z because this is also a transversal. So this is also angle Z. So these two things we can easily prove by, you can say, parallel lines. So simple. Now we know that these two angles are same. Also, this angle is common, which means clearly you can see that this triangle, because all the angles are what? C, Y, Z. So yeah, that means triangle FCD and this whole triangle, they both are similar. Why? Because obviously you can see their sides are entirely different, but their angles are same. So we can say triangle FCD is similar to triangle BCA. One thing. Another thing it's mentioned that triangle EFD and BCA are similar. So which means triangle EFD are similar to triangle BCA. this triangle is similar to this one. If this is similar to this one, this is similar to this one, that means BC is common in the both. I can say triangle FCD is similar to triangle EFD. So triangle FCD is what? I'm just deleting it, but because it's a 5 marker as well as it's a geometric proof, you have to give the reason. If I'm saying this is why, you have to give the reason that since FDGH is a trapezium, which means FD is parallel to GH, and thus angle Y is equals to angle B is equals to F. Clear? Now we have to see angle triangle FCD, that means this triangle, and triangle EFD, these are similar finally. So I can say that this angle is clearly equal to this angle is equals to this angle, and this angle is equals to this angle, and hence we can prove angle X is equals to angle Y because these two are similar. So I can say hence angle CFD is equals to angle HGE, which is equals to X is equals to Y, and these two angles are equal. But as I said, it's a geometric proof, you have to give reasons. Moving on to the next question. In the figure given above, angle BEC is 100 degrees. So angle BEC, that means this one, is 100 degrees. Angle EDC is 30. So angle EDC, this one is 30. And angle it's BAC, that means this is, obviously it's not up to the mark. This is not like as per, though it looks like it's 90 degrees, it's not. Angle BE equals angle EC. So BE equals EC, which makes this whole triangle an isosceles triangle, which means this angle is equals to this angle. And by angle sum property, I get to know that if this is 100 degrees, sum of each one will be equals to 80. And then each one is of 40 degrees. That means angle B plus angle C plus angle E is equals to 180. Angle B and angle C are equal, so I can write 2 times angle B plus angle E is 100 equals 180. 2 times angle B is 80 and angle B is equals to 40, which means each one of them is 40. Always give the reason, it's a geometrical proof. Again, if this is 100, this is going to be 80 because angle in a line is 180 degrees. So which makes this be 80 degrees. Apart from that, if this is 30, let me show you. If this is 30, this is 80. So again, by angle sum property, I can say this one is going to be 180 minus 80 plus 30, which will give you 70. So which means this angle is going to be 70 degrees. Again, I'll be applying the angle sum, that means this one. Angle in a straight line. Angle in a straight line is 180. If this is 70, this is 40, then this is what? 70 plus 40, which is 110, and this remaining one is 180 minus 110, which is 70 degrees. Now look at this triangle. This one, the last triangle remaining, this one. In this also I'm aware of 2 angles. This is 30 degrees. This is 70. So this is going to be 100 subtracted from 180, because again I'll be applying the angle sum property, so which is 180 minus sum of the other 2 angles, which is 70 plus 30, which will give me answer as 80 degrees. So if I compare this triangle BCA, this triangle I have drawn separately. This angle is 80 degrees, this angle is 30, this angle is 70. Now if I say this triangle, because we have to prove triangle ABC, I have drawn now triangle ECD. This is ECD. So if I draw triangle ECD, it looks like this, ECD. This angle is 30, this angle is 80, and this angle is 70. I can clearly see their corresponding angles are equal, 70, 70, 80, 80, 30, 30. That means, hence, since all the angles, all the corresponding angles are equal, we can say these two are similar. So since all corresponding angles are equal, triangle BAC is similar to triangle ECD. Moving on to the next one. If AB is equals to 4, then calculate the length scale factor. This is length scale factor. So if AB is equals to 4 centimeter, AB is equals to 4 centimeters, then we have to calculate the length scale factor. Okay, now let me just delete this whole. If AB is 4 centimeters, AB, this one, this is 4 centimeter. Then we have to calculate length scale factor. Length scale factor can be calculated if you will find the corresponding sides. So we can calculate the corresponding sides, and for that we have to calculate one thing, that let me find any particular side. We are aware of two angles. This angle is 80 degrees, this angle is 30 degrees, and this angle is 70 degrees. So if I'll apply the sine law, I'll be able to calculate the side BC. So on applying sine law or sine rule in triangle ABC, so AB is 4 centimeters over sine of angle which is opposite to this side, BA, then opposite to side BA is angle 70. So sine of 70 degrees is equals to, we are calculating BC, so BC over, and the angle opposite to BC is clearly 30 degrees. So this is going to be sine of angle 30. From here BC is equals to 4 times sine 30 degrees over sine 70 degrees. Now we have to calculate side BE and CE because they both are basically equal. So what you need to do is just apply cosine rule. So only in triangle BEC I'm applying. So I'm just drawing triangle BEC. So triangle BEC looks like this. BEC, and it's already given this is 100 degrees and we have calculated is at 2.12, and we know BE is equals to AC, which is already given in the question. So let's say this be x, so this be x as well. On applying cosine rule, BC squared is equals to x squared plus x squared minus 2 times x, which is x squared, cos of 100 degrees. And I assume you all are aware of how to apply cosine rule. If you're not, then I have already made the video on sine and cosine rule. You can go over. I will attach the link in the description box. BC squared is 2.12 whole squared, which is 2x squared minus 2x squared cos of 100 degrees. From here, we have to calculate x squared. So I can take out x squared as common. So 2.12 whole squared is equals to x squared times 2 minus 2 cos of 100 degrees. So x squared is equals to 2.12 whole squared over 2 minus 2 cos of 100 degrees. And if we solve this, we'll get the answer as, this is equals to 1.914, and then we have to take the root of it. So x will be root of 1.914, which is equals to, this is equals to 1.383. If we go back and we have to find length scale factor, and we know the triangle BCA and this one, these two are similar. Now we have to see which two sides are corresponding. So in this triangle, this one, we can see that ED is the line which is having two angles 80 and 70. So in another triangle, we have to find that line which has angles 80 and 30, which is BA. That means which two sides are corresponding? BA is corresponding to ED. So if I want to calculate the length scale factor, I have to divide BA over ED. So BA is 4 and ED, which is this one, and unfortunately we don't have ED. Let me see the other one if we could. So let's take the one which is having 80 70, which is EC. So EC 80 70, and that line which contains 80 70, which is BC. So EC and BC. So now the next corresponding sides are EC and BC. Let me see, we know EC. Yes, we know EC that we have just calculated, which is 1.383. So EC we know 1.383 and it's corresponding to BC. So we can say that 4 over 1.383. That will be length scale factor, which is equals to 2.89. So we got the length scale factor as 2.89. Moving on to the next one, calculate the ratio of area ABC to ECD. So ABC is this one and the other one. We already know these two are similar. We already have the length scale factor. So obviously the ratio is what? The area scale factor. So it's going to be 2.89 whole squared, because we know that length scale factor is always a square, the area scale factor is always the square of length scale factor. So it's going to be square of 2.89, which is 8.35 to 1. So 8.35 will be the area scale factor, or the area of ABC to ECD. Okay, now in the figure given above, ABC is an equilateral triangle where AC is 8 centimeters. So one by one, if the whole AC is 8 centimeters, which means each side will be 8 centimeters as it's an equilateral triangle. Always mention, if you're writing, it's a 5 marker, so you just have to write then AB is equals to BC is equals to AC is equals to 8 centimeters, because it's an equilateral triangle. The next is BH is perpendicular to AC. This is 90 degrees because it's perpendicular, and DE is parallel to AC. This is parallel to this one. And DA is 3 centimeters. This smaller part is 3 centimeter, which means clearly BD is 5 centimeters. So BD will be 5 centimeters. Obviously, because the whole is 8 and DA is 3, so the remaining part will be what? 8 minus 3, which is 5. Now it's mentioned that we have to find the ratio of triangle BDI to triangle TAF. So that means BDI, this one, this is BDI and this is TAF. If we'll be able to prove these two triangles similar, it's very easy for us to find the area of it. Because we are aware of only one side, so it's not easy for us to find other sides and everything, and not particular angles are even given, only 190 degrees, so it's very hard. So best thing is, if we'll be able to prove that these two triangles are similar, we can easily find their areas ratio. So one thing is mentioned, that DE is parallel to AC, and if it's so, then BA will be transversal clearly, and then this makes this angle same. This angle and this angle will be same. So our focusing triangles are this triangle and this triangle, and we have to prove all the corresponding angles be equal. In this way, we'll be able to prove these two are similar. Next is this is 90 degrees and these two are parallel. So again, by corresponding angles, this is transversal. So if this is 90 degrees, this angle will also be 90 degree. So this is 90 degrees, which means that this is 90. So obviously this is going to be 90. And this too. So what we know that this is 90, this is 90, this is 90. Obviously this is going to be a rectangle or a square. That means all the angles are 90 degrees in this case. So if this is 90, then this will also be 90 degrees. Now in these two triangles, two corresponding angles are equal. That means angle BTI is equals to angle BAH, and angle PIT is equals to angle DFA. So DFA, which proves that triangle BDI is similar to triangle DAF, and if these two are similar, so their corresponding sides will bear a common ratio. So length scale factor will be the ratio of their corresponding sides, which is 5/8. They're asking you to calculate the area of triangle BDEI to triangle DAF, which means obviously the corresponding side of this should be, because if this is whole, this is 5, or what is given, AC is 8 and DA is 3. This is 3, sorry, this one is 3. So it's 5/3, not 8. By mistake wrote 8. It's 5/3. So obviously the area will be 5/3 whole squared. That will be the ratio of this. Either you can leave it in a fraction, or it would be better if you convert into decimal, which will give you answer approximately 2 equals to 2.78. And that's the ratio of area of BDI to DAF. So that's it for today. We have done some questions on similar figures, and in the next class we'll be doing some other questions, other topics. And meanwhile, if you're looking for the live classes, obviously let me tell you one thing, the classes being recorded and when you are in front of a teacher, it's entirely different. Maybe sometimes in a recorded session it's very hard to understand some topics, but if you will be in a one-on-one classes, it will be much more clearer. If you're not able to get it, you can ask 100 times. Me and my tutors are there to tell and to clear your doubts. So that's it for today. Bye everyone. Take care.